Well, good afternoon, everybody. When I became president of the Botanical Society of Scotland, which was a while ago now, it was in 2012, I thought we needed a project to galvanize our members. They didn't all want to be galvanized. And I wanted to reach out to non-members who might become members, and non-members who were just members of the public with an interest in plants, and there are many such people. So after much discussion, we launched the Urban Flora Project to record our botanical observations in towns and cities all over Scotland. And many of these towns seemed to be under-recorded, hadn't been visited all that much by botanists, and we thought we could make some contributions to the efforts of the Botanical Society of Britain and Ireland to fill some of the gaps. And I think we've done a certain amount of gap filling. Now, we estimated that the project would last for about 10 years, and we've been going for 8 of those 10. And still we've got a lot to do, some final recordings, and also we want to enter the phase of data analysis leading to publications and a book, and to create a long-term archive, a user-friendly archive that people can interrogate. Now, we differ from the BSBI in several ways. First of all, we place emphasis on recording the habitat, as my background is ecology, and habitat is so important. And we use a classification system based on one we used in an earlier project called Plant Life of Edinburgh and the Lothians. Those of you that are of an age will remember that project. Secondly, we're different from the BSBI in that we record bryophytes and fungi. We think that fungi can be thought of as honorary plants, and we'd like far more fungal records, but that may be another project. And thirdly, we're interested in questions like why. So why are plants distributed in the way that they are? That seems to me, as an ecologist, to be a key thing that we should be addressing when we come to data analysis. So this is a quick overview, repeating some of the images that we saw in Jonathan Silvertown's introduction this morning. And you can see that we have covered about half of all the towns and cities. And we have found rather a lot of species. We've got about 90,000 records. And we've got about 40 people registered as recording with us, some much more active than others, as is usually the case. In nearly all projects I've ever been in, a small number of people have contributed the most, but we still like to have contributions from everyone. So that's a kind of overview picture of what our project is. And there are enough records now to be able to think about what is it we've got. We must look back at the data and say, how well have we done? And you can see that most of our records come from the category that we call roads, paths, and pavements, shown here. And this has various subcategories, one of which is railways and roadsides, footpaths, cycle paths, all the things that are routes through which people travel. And another category which is big in terms of where we've been and what we've recorded, that's gardens. And gardens aren't usually private gardens. We do sometimes look over the fence, and we might knock on the front door and say, can we look at that plant growing in your lawn? It looks like a rare orchid. It doesn't happen very often, but we don't go to people's gardens routinely. But we do like to go to allotments, car parks, churchyards, all those places with green space where plants grow. Car parks are remarkably interesting. You don't think of them as such, but you'll see that you can find quite a lot of rather rare things around the edges of car parks. Okay, now, whoops. So we can draw up lists. The first stage in the analysis is to draw up lists and look at the top 20 recorded species in broad habitat types. And we mix the bryophytes in here with vascular plants. And so you can have a kind of a league table of how often do these plants turn up. And we'll be able, in the end, when we do analysis, we'll be able to identify attributes of species, attributes which mark them out as a garden lover or a building lover or a road lover. And we've only just started that, and we have useful databases. We rely quite a bit on Plant which is an amazing database which was first published by Mark Hill way back, but it's still very useful. Okay, so that's the sort of things we're doing. Now, I'm going to focus on a few species in a short talk, a few particular species. First of all, these are the ones that surprised me when we found them. So I didn't have a huge background in plant recording when I started this, and others around me knew more than I did. And as we went round and we made botanical lists, we found things that challenged me and sometimes challenged the people I was with. And here are some that turned up unexpectedly or have been increasing sharply. And you can see we've got the few-flowered garlic, which is now pretty common, and the three-cornered garlic. We've got the strange little plant called the New Zealand bittercress, which most of you won't know, but it can be found in the spring in the Royal Botanic Gardens. We've got a funny little crassula, which does turn up in car parks and churchyards, and I think was first recorded in Scotland somewhere up in East of Ross. I think it was probably Brian Ballinger who was the first person to see it. And then the great lettuce, a big tall plant, and the Himalayan honeysuckle, and two polypogons, which I'll talk about in a minute, and then a strange Senecio iniquidens, the narrow-leaved ragwort, and a tiny little plant called Mind Your Own Business that I first saw outside David Chamberlain's house. I naturally thought it was a bryophyte, but when I got down on my hands and knees, I could see it was not. So that's an interesting little plant. It's changed its name, but I'm going to use the old name. So we looked at these plants. Now, the water-bent grass, Polypogon viridis, I discovered within 50 meters of where I live, and I couldn't identify it. And I was with Lynn Jones at a horticultural show, and I told him about it, and I showed him a picture, and he identified it immediately. Do you remember that moment? And I was eternally grateful to you. And it's very common. It's very common in my part of Edinburgh, South Edinburgh, and in North Edinburgh too. And you can see that before 1930, it was present. So there was a record there, quite some records in London, and a few scattered records, particularly in the southwest. So that was 1930. And then if we look at how it has spread, this is 1945, no change. Up to 1969, still hardly any change. 1986, a little more perhaps. And then it really got going in the last few decades. So this is up to 2009, up to 2019, and still it's quite modest in Scotland. It has proliferated a little bit up here, but not very much. But if you look at England, it's become widespread in some parts of England, and you can see it also colonised in parts of Ireland. And there is an interesting paper that says that it's the most rapidly moving of all the species we have. So you might not know it, but I think that you will see it before long. And then I spent much time trying to identify the fleabanes. So this is a fleabane I saw during lockdown. This one is growing outside the Edinburgh College of Art, the back entrance, rather fine specimen. And I first of all thought it was canadensis, and then I started looking around, and I found that there are at least there are 4 species, and you can identify them. There's a very nice article in the BSBI News in 2017 by someone called Leiby. Somebody may know his name. I don't hear it. But there's a nice article. And so these 4 species, they come from the New World, and they've colonized the Old World, and they're still increasing in area. And this is, again, the distribution from before 1930. And you can see it was already here to some extent. And quite often when you look at plants like this, you find them in Edinburgh, you find them in Cambridge, you find them in London, you find them in Oxford, you find them where there are botanic gardens. I wonder why that is. And of course there is always an issue when looking at botanical data, an issue about recorder effort. So recorder effort, ideally you'd want equal recorder effort on every square all over the country, and then you would be able to make complete, unequivocal statements, but you haven't got that. You have to make do with what you have. Okay, so that was how it was, and then looking at how it became, you can see it rapidly colonized the southeast, and I've seen it many times when I've been down to visit my relatives in North Buckinghamshire, and you find it around Milton Keynes a lot. But if you look at it in terms of where it has expanded its range, it's expanded its range not very much in Edinburgh until recent decades, and then it has. And it's also increased its range up here around Elgin. But look, it's actually very, very common weed now over much of England and a good deal of Wales. So, and I feel that there are 4 of these species, and I think they're often confused. And then the great lettuce. I came across the great lettuce down in Leith, and I hadn't realized it was a native. It is a native plant. You can identify it by its lovely deep purple achenes, and it's very tall, like no other lettuce, and it tends to angle its leaves in such a way to protect itself. And so you can see that it's native over much of Europe and quite a bit of North Africa. And this is how it was in 1930. And you see it's present here in London, in Oxford, and quite a bit in Edinburgh and Glasgow. Now, if we move on and look at what's happened to it, it's increased, rather like the other species, but in a different sort of way. It's increased, and now it's not uncommon in the southeast, and has increased rather gradually this time, instead of in a sudden jump. And now we move on to the annual beard grass, which if you follow our blog called Plant of the Week, which I'm sure you all do, you will find it in this week's Plant of the Week. So here it is. When I found it in 2020, I was very pleased with myself, but it wasn't the first ever record for around here. And it also is a native, which surprised me because it has an exotic look about it. And here we are in 1930. It was already, you had a good foothold in Scotland already, and of course in London and in Oxford as well. And let's see what's happened to it. And we can see that it has increased. It has increased not all that much, but it's certainly quite a common plant down in the southeast. And so these are some examples. I think they're examples of what we might think of as poleward movement. Plants have tended to move northwards. This is what you get by looking at the species distribution maps. And there was a most intriguing paper by Quinton Groom, who some of you may know, and it was about the poleward movement of British native plants. So there was the idea that plants are moving to the north because the isotherms are moving north. It's getting warmer all the time, and so new sites become open to warmth-loving plants, and the plants move northward in response. And what he did was, must have been a lot of work. He took, for Scotland or for North England, he took the BSBI data, which gives you latitude and longitude, and he found the median, the kind of center of gravity, and he looked at how this had changed over the years. And he found that for Scotland, indeed there is a northward movement, a poleward movement. There's a tendency for plants to move north. Likewise, in England, there is a weaker but still a tendency to move north. And when I saw this graph, I thought, oh, that's to do with climate change. But then I looked at the title. He says, the fingerprint of climate change is not evident. I do like it when people's titles tell the story in a flash, and that's what he did. And so that got me thinking, and I would like to do some of that work myself, although it's quite a big job. So, but it made me look at temperature data. Now, the Met Office these days is much better than the Met Office used to be in terms of access to data. So I found a nice site where I could look at the temperature trends, so I could look at to what extent has warming in Scotland made us anything like as warm as the south of England. And clearly it hasn't. Every time you go down to London, you realise this is not the same as Edinburgh. And so what we've got there is, this is a running mean. I've taken 10-year running means, because if I didn't, it would just look a huge scattergram. Wouldn't be able to make sense of it. So in southern England, here we are. This is the summer air temperature, and there's an increase. And you look at the different parts of Scotland, West Scotland, East Scotland, North Scotland, and there's a similar increase of about 2.2 of a degree per decade. And it really got going about 1990, but we're still, in Scotland, we're much, much colder than the south of England, and it'll be a long time before there's any kind of catching up. And just to show, this is the July temperature for 2020, and you can see that there's a big warm blob down in the southeast, which coincides more or less with where many of the species that we've been talking about, where they do well. Now, moving on, how do plants get about? Now this, I think, is the part of my talk where I got a bit carried away. and you can see that if we imagine a pristine environment, then seeds and other propagules and fragments of plants, they get stuck to birds' feet. I was always told this as a child. That's how fish get about, and frogs and newts and all kinds of things get stuck to birds' feet. And so they get transported around the countryside. And there's also wet and dry deposition from the atmosphere, much as was talked about by Sim Tang in her talk, but for gases. So these are particles are very small, and so they're washed out of the atmosphere. And if they land on a pristine environment, imagine some hills in the borders, they may or may not find a site to germinate. But if they land in a city, it's a different matter because the city is a patchwork of wet and dry, of hot and cold, of sun and shade, and of limestone and acidic substrates. So there's a lot of heterogeneity in a city, as we've heard this morning in all the talks that we've been listening to. So now we don't live in a pristine society, we live in the Anthropocene, and so we've got seeds and other propagules stuck to tires, stuck to boots, drawn along in the wake of trains, in the flower pot, when people buy things from garden centres, and imported soil for landscaping. So all of these bring seeds into the city. The city is getting deluged with seeds that come in accidentally because of human actions. And an interesting question is, how big effect is this? Now, I found the data, the Office of National Statistics is always interesting. And I found this graph. It's how many vehicle kilometres are travelled in Britain since 1950. And look, my goodness me. Look, it only pauses occasionally when there's an oil crisis, or in fact when there's COVID. So we have something like, I think it's 10,000 kilometres per person, or is it 100,000? You can do a quick calculation, divide this by 60 million. It's a lot of miles or kilometres. And so the vehicles are moving all over the place. And for those species where we've got a sort of tracer, like the halophytes that come from the seaside, like Cochlearia danica, we see this. We see this graphically when we look at the distribution patterns. We see that they occur along roads. That's because they're picked up. They're picked up by vehicles, and they're scattered along the roads. It's so obvious in the case of a halophyte because it's a marker. But it must happen with other species that also get deposited by the roadside but don't find favourable conditions there. Now, I want to tell you about something which I did during lockdown. I tried to do some analysis, and this time I used the BSBI data, which is freely available. And what I did was I constructed a transect of 10 kilometre square. So each one of these squares is 10 kilometres by 10 kilometres. And I went from Edinburgh to Glasgow. So this is densely populated, this is densely populated, this is much less densely populated. So, and I downloaded all the BSBI data, and I counted the species. And let's see what we found. Well, we found that, first of all, let me explain the axes. This is the number of species in the BSBI record, and this is distance from Glasgow. So Glasgow is here, Edinburgh is here. And look, what we find is that Edinburgh and Glasgow, they both have a lot of species recorded by generations of BSBI recorders. And good strong data sets, plenty of records. And as you get into the underpopulated regions, there are fewer. And then it goes back up again when we come through Livingston, comes back up again. And so we have this interesting graph. We have to be a bit careful about the interpretation because we've already talked about pollution deposition and nitrogen, and topography has something to do with it because there are some hills in the middle here. And the alien species, which I've shown in red, they show the same pattern, particularly sharply in the case of Edinburgh. So that's quite an interesting result. It requires interpretation and thought because there are many confounding factors in the analysis of such data sets. And what I did, I thought I was being very cheeky. I looked at all the towns and all the places in this transect, and I looked up in the census data to find how many people live there. And I found, therefore, that I could talk about how many humans live in each of those 10 kilometre squares. And then I turn them into logarithms, like every good scientist does. And if you take the logarithm of the human population and you plot it against a number of species, then there is a linear correlation. Now, we tell our students all the time that correlation doesn't mean causation. We have to be very careful. And of course, I'm very careful. And then I also looked at the alien percentage. So you can easily find out if a plant is alien. You can use lookup tables and Excel spreadsheet, and in no time at all, you can get a result like this. So the percentage of aliens increases with the log of the human population. And I found that a very important result, and one that I might repeat for many other places, but we'll see how we get on. So there is a relationship between the human population at a broad scale and the total number of species. So we think about this again. We go back to this diagram. So all of those items there in the yellow box, they're all to do with humans and how they move about and what they do, that general human activity. And only this one is a natural process. So we're doing something which is probably a larger process than the natural one, the birds and maybe some ants and various other creatures that move seeds and other propagules around. And then, this is something I've been thinking about for a while, there is a positive feedback cycle. So what we've got is that all of these people who are travelling about the country carrying all these seeds inadvertently on the rubberized bottoms of their cars and shoes. So they bring these seeds in, and the seeds, many of them find a good place to germinate in a city. And then they go out, and they go out for fishing or football, and they take some seeds back with them. And this is a positive feedback cycle. And to some extent, you can think of the city as a seed source, and seeds go up into the atmosphere by birds and wind, and that enriches the surrounding countryside over here, and some of it goes back. So I think there is a need for a little bit of mathematics, which I haven't done, to look at this idea that there is a positive feedback cycle that amplifies the presence of plants in cities. Obviously, the climate has to be right. And it's interesting, I did another exercise you can find in the data set of Walker and others, an article on Britain's changing flora. And this is a map of the aliens, the neophyte aliens, not the archaeophytes, just the neophytes. And this is a map of the temperature, the Met Office temperature, which is in this case for 2020. And you do see a remarkable similarity in the pattern. You see there's a pale bit here and there's a pale bit here. And if you study this map, if you stare at it for some time, you will find remarkable coincidences. You usually have a warm zone coming up like this, and you usually have more species coming up here. So the warmth does indeed attract alien plants particularly, and probably also native plants, which don't show up so well in this image because there are so many of them, and it doesn't make a nice graphic. So there is this magnetism of warmth that attracts plants. So that's more or less the end of my talk. So I'm saying that there is such a thing as poleward migration, as Quinton Groom said. And he said you could think of it as a diffusion. And diffusion has always interested me from doing school chemistry. Diffusion is wonderful. So diffusion is not molecular diffusion, nor is it turbulent diffusion, but it's a kind of diffusion that's aided by the movement of people. So the more people are moving about, the faster is the diffusion process going on. In a cold country like we are, it's pretty inevitable that we'll get more species coming in from warmer regions, and particularly we think of Europe, but we also must think of garden centres that are providing species that are alien here but find a home in the Mediterranean or the south of Europe. And warm regions are being colonised by, we can call them thermophilic species, and these are often aliens. And I have also looked at where the aliens come from, and indeed they have a thermophilic nature. So thermophilic aliens are colonising the country, and it's being aided by all this dispersal that we all do whenever we go out, whenever we drive somewhere, whenever we go on the train as well. So that's the end of my talk, so thank you. Graham, first.
Thank you. Just very quickly, you made the nice point that where there are more people, you've got more of your plants, and you also linked it to temperature. But I was just thinking that on the map in your previous slide, the areas that are warmer are also areas that have more people. Yes. So how confident are you that one or the other is the driver? Because they seem to be somewhat combined. And you also make the point they could be operating synergistically.
Yes, that's all right, yes. I agree with you, and I made the point that correlation doesn't imply causation. And I think it's very hard to separate, because people live in warm places all the time. That's where, if you look at the distribution of cities and towns in Scotland, they're all in the warm places. There not very many on the west. So I think you can do it by modelling, which I haven't done so far. And you can look at, there are some data from Sheffield, from Ken Thompson, on the seeds he finds on car tyres and in soil delivered by contractors who just order some soil that comes from Southampton, take it to Edinburgh and plonk it down. That kind of thing goes on. So you can play about with modelling, and that's one possibility of trying to disentangle the processes you're talking about. We might want to collect data on what do we find up here on motor vehicles. That would be an interesting undergraduate project. Need to do a risk assessment.
Another question potentially on modelling is, you showed that wonderful transect between Glasgow and Edinburgh. Of course, we've lots of botanists in Glasgow and Edinburgh. How do you exclude recorder effort and recording effort?
I've done that, yeah. So what I've done is I take the data from across that transect and I plot recorder effort in terms of how many records are there. I do essentially a species accumulation curve. So if you look at Edinburgh, you've got which way around? Yeah, this way. So this is the recorder effort, and for a small amount of recorder effort, the number of species found goes up sharply, and then it doesn't ever level off. It's still going up, but it's not so steep. And then you go to West Lothian, far fewer records, but it's still beginning to level off, and you can fit a curve. There are various, in our code, you can call up species accumulation curves, and you can estimate how much recorder effort would you need in order to capture 95% of all the species that are there. So there is a way, and I have tried doing it, I think reasonably successfully, to try to measure recorder effort and to remove it from the data. Actually, it doesn't make all that much difference, is the answer. You still get the same pattern.
Yeah, on the Scotland is still much colder than England even was in 1900. In midsummer, is it more useful to know what is the difference in mean temperatures in January In terms of plant survival?
Yeah, I could try doing that. This was my first cut. Look at summer. I could try. The Met Office divide the data up into months, so you can try every month of the year. It would take some time. From what we know about plants is that woody plants need winter chilling, but I believe winter chilling occurs pretty much all the time at the moment. There might be a time in the future when there's not enough winter chilling for the trees and shrubs. Yeah, I think it would be an interesting, again, it would be an undergraduate project to look at the same data, but to filter out the months of the year and find out which months of warmth are the most important. My best guess is that it would still come out to be something like the length of the summer. The length of the summer seems to me to be what determines how well plants grow, how successful they are.
Yeah, growing season. So on the same point then, if we're saying, or Quentin, I've forgotten a second, Bloom, was saying that there's no evidence that it's global warming that's the cause of this, what is? Do we even have a guess? And if it's not that?
We're saying that down in the southeast of England, it is really considerably warmer. It's rather like the north of France was. So you can grow wine in the south of England, whereas you couldn't previously. And people are saying south of England champagne is better than champagne from France. So we know that there are many European species that will do very nicely in the south of England, but it's going to be a long time before we can grow wine in Scotland to any commercial success. So I think that what we can say is, what I've tried to say is that the poleward movement is probably enhanced diffusion, but some of it may be climate warming as well. And I haven't been able to properly separate them, and that was the essence of Graham Stone's question.
I have a question about big data, because you have a big data set, and obviously as you move into the interpretation phase, all this data has to be analysed and significance sought. A friend of mine did a big data set on where people die, and discovered, he said, I bet you find there's a correlation that most people die downstream in a river system from where they were born. And sure enough, this proved to be true. But it is of absolutely no significance. So you said that correlation doesn't equal causation, but correlation between two big data sets might not even be significant.
Yes, I do remember similar data on the correlation between birth rate in Central Europe and the number of sightings of storks. No, you're quite right. I probably should take some advice on it, but I can do. Some people would naturally go to multivariate analysis, and I don't do that because I think that hides what's going on, and I'd rather have a mechanistic model to enable me to understand the power of the various independent variables. I think that gives you a way in to unpicking these correlations where there are so many intercorrelated variables going on. It's a general problem in ecological research. The question you raise plagues everybody doing ecological research because there are so many variables and they're quite often completely interrelated. So I don't have a straight answer, except I still think that modelling the processes is a way in towards answering the question. But thank you, Michael, for that question.